Hey, Jason here from Simply Swider. If your Kenmore oven just died and won't heat up, don't panic. I'm about to save you hundreds of dollars and your dinner plans. Some problems that prevent a Kenmore gas oven from heating are misdiagnosed as a bad control board or gas valve, which can lead to unnecessarily expensive repairs. In 80% of cases, it's actually a $30 part you can replace yourself in under 20 minutes. Before we get started, if you run into any questions, jump into our Facebook group. Links in the description. We've got thousands of people helping each other fix their appliances, and I pop in there daily to help out. Now, here's the thing about oven heating problems. What you see isn't always what's broken. In electric models, we're looking at burnt out bake elements about 50 to 86% of the time. Gas ovens, 30 to 55% of the time, it's a weak igniter that glows but can't actually open the gas valve. The big misdiagnosis happens because people see that orange glow and think the igniter's fine, so they start replacing expensive stuff like control boards and safety valves. These ovens live under extreme thermal stress, and that self-cleaning cycle you ran last week, that might have been the final straw that pushed your weakened components over the edge. You'll see the oven display working perfectly, but zero heat when you're trying to bake. The broiler might still work fine, but that bottom element just sits there cold. What's happening is the internal wiring in that coil has broken from thousands of heating cycles or grease buildup, creating hot spots that melted right through the casing. Here's your two-step diagnosis. Step 1. Visually inspect the bottom heating element for cracks, blisters, or burn marks. Step 2. Set your multimeter to ohms and touch the probes to both element terminals. A good element reads 10 to 50 ohms. If you see OL or infinity, that element is dead and needs replacement. Don't get fooled if the element looks perfect from the outside. I've seen plenty of elements with internal breaks that you can't see until you test them. Here's something that catches people off guard. Some models have hidden elements under a metal cover, so you might need to remove a couple screws to actually see what's going on. You'll notice the igniter glowing bright orange or red, but the burner never actually lights up. You might even smell a little gas, which means gas is trying to come through, but there's no ignition happening. What's happening here is that silicon carbide igniter has degraded over time. It still glows, but it's not drawing enough amperage to open that safety valve. Here's how to test it properly. You'll need a clamp-on amp meter, about $25 at any hardware store. Clamp it around one igniter wire and start your oven. A healthy igniter pulls 2 to 3, 6 amps. Anything under 3 amps means it's too weak to open the gas valve, even though it still glows bright. If it's pulling less than 3 amps, that igniter is weak and needs to be replaced. This is where most people mess up. They see that bright glow and assume the igniter is fine, so they go and spend $150 on a new gas valve when a $30 igniter would have fixed it. I've seen this countless times. The igniter looks perfect, but those silicon carbide elements just thin out over the years until they can't do their job anymore. You'll see error codes like F1 or F11 flashing, or maybe the display works, but there's no voltage getting to your heating elements. Sometimes the display goes completely dim or dead. In some Kenmore ranges, the electronic control board sits close to the oven vent, and over time, heat exposure may contribute to damage of components like capacitors or relays, which can lead to control board failures. Here's what you're going to do. Test for voltage output at the board terminals when you call for heat. You should see 120 volts going to the igniter or 240 volts to the bake element. No voltage output means the board's not sending power, even though it might look fine. Sometimes you'll see actual burn marks or swollen capacitors on the board itself. This is an expensive fix, anywhere from $100 to $700. But don't replace it until you've tested the simpler stuff first. You'll see F3 or F4 error codes, or the oven thinks it's reached temperature when it's still stone cold. Maybe it overshoots by 100 degrees and won't stop heating. What's happening is that RTD sensor's resistance has drifted out of calibration, usually from moisture getting into the probe or just internal component degradation. Here's what you're going to do. Test the sensor resistance with your multimeter at room temperature. At 70 degrees, you should see about 1080 ohms, give or take about 5 ohms. If it's way off from that range, the sensor's done. This is actually one of the easier diagnoses because the oven usually throws a specific error code that points right to the sensor. You'll see the display working normally, but absolutely zero heating action. No bake, no broil, nothing. This usually happens right after running a self-cleaning cycle. What's happening is that thermal fuse acted like a circuit breaker and blew to protect the oven from overheating. Here's what you're going to do. Find that thermal fuse and test it for continuity with your multimeter. A good fuse shows continuity. A blown fuse shows nothing. If it's blown, you got to replace it. But here's the important part. You also need to figure out why the oven overheated in the first place. Make sure the oven's cooling fan is working properly, since poor cooling can often contribute to overheating and electrical faults that may trip breakers or blow fuses, but also check for other common causes like element faults, wiring problems, or circuit overloads. Let's talk real numbers here. The cheapest fix is usually a $10 thermal fuse if you're lucky. Most common waste of money, people spending $150 on a gas safety valve when a $35 igniter was the real problem. Biggest expensive mistake is replacing a control board for $300 to $700 when it was actually a $25 temperature sensor. Here's the money breakdown. DIY repair costs $10 to $150 in parts. Professional repair adds $150 to $200 in labor, plus a $75 service call. My rule: if total repair costs exceed $300, start shopping for a new oven instead. A decent replacement runs $500 to $800, so you're better off upgrading than throwing good money at an old unit. Here's what each part actually does and how to test it properly. That bake element converts electricity to heat through resistance. Test it with a multimeter for 0 to 50 ohms. The gas igniter needs to draw enough current to operate the safety valve. You need a clamp-on amp meter to verify 3 plus amps. Control boards often manage most of the logic and power distribution. Test for proper voltage output during a call for heat, depending on the system. Temperature sensors monitor internal temp and send resistance signals back to the board. Should read 1080 ohms at 70 degrees. Thermal fuses are one-shot safety devices. Simple continuity test tells you if they're good or blown. The key is testing with actual meters, not just visual inspection, because these components can fail internally while looking perfectly fine from the outside. You can get a basic multimeter for $20 at Harbor Freight, and it'll save you hundreds in wrong part purchases. Kenmore ovens, especially the Frigidaire built ones, often have a design issue where they can mount the control board right above the door vent where it may get blasted with hot air during cooking. The 790 series has another issue with hidden bake elements that you can't see without taking stuff apart, so failures stay invisible until you test them. Gas models often use silicon carbide igniters as a standard wear item. They can be designed to fail every 3 to 5 years in many models, so don't be surprised when yours goes bad. Some dual fuel ranges use relay boards to control their electric oven elements, while the cooktop uses gas. And in theory, the added complexity and cycling could contribute to relay wear, but there isn't clear evidence that dual fuel models as a group wear out relays faster than comparable single fuel units. Pay attention to these warning signs before you're left with a cold oven. If your oven's taking way longer to preheat than usual, that's often the first sign of a weak igniter or failing element. Clean up spills immediately, especially on that bottom element, because grease buildup creates hot spots that'll burn out elements prematurely. If you hear clicking sounds from the control panel but nothing's happening, that's usually a relay starting to fail. Power surges from storms or utility issues love to fry control boards, so consider a surge protector for your kitchen. And here's a big one: don't use your oven to heat the house during power outages. That constant high heat operation can often cook your components and create a dangerous carbon monoxide situation depending on the vehicle.